Podcast is now starting. All attendees are in listen-only mode.
Hello, everybody. This is Susan Del Rosario from Tutor.com. Thank you so much for joining us today. We're going to get started in just a couple of minutes, but I see several people are still logging into the webinar and getting their audio set up, and so I want to give them time to do that. While we're waiting for all of the rest of the attendees to join us, I just want to run through a couple points of information that will be important for you throughout the webinar. So the first thing that I always like to do is make sure you guys are able to hear me. And the way that we do this, because all of the participants are on mute, except for those of us presenting. That means you can't respond to me except through your GoToWebinar control panel. And so right now, I'd like you to look on your screen and see if you can find something that looks a little bit like this. Mine is the presenter's version, so it will look a little bit different, but you should be able to locate a GoToWebinar control panel. If you don't see it, look for a little orange arrow like this and click that, and it should expand. When you do this, one of the very bottom buttons down here below where my pencil would be, you're going to see a little hand. Go ahead and click that hand in order to raise your hand and let me know that you can hear me and that you found your GoToWebinar control panel, because you're going to need that throughout the presentation. All right, I'm seeing quite a few hands going up here. That is wonderful. That tells me the audio is working well. Excellent. All right, so now that you've located this GoToWebinar control panel, I want you to find two different sections. The first one is questions. Okay, since you guys are on mute and cannot speak to us, we have to have a different way for you to ask your questions and engage with the webinar. You're going to do this through the GoToWebinar control panel. And so you should see the word question. If the arrow's pointing to the right, click it and it will expand. This is where you can go ahead and enter any questions that you may have. We'll pause throughout the presentation, throughout the webinar and the lesson in order to answer your questions and work them into the lesson plan. You should also see a section called handouts. Now, if you don't see handouts, go to the top and click view, and under view, there should be a handout option for you. Once you have gotten that handout option expanded, you'll see that we've uploaded a PDF version of the presentation today. So if you would like a copy of the presentation, just click on the name here, the C+L webinar, Come and Learn webinar, and that should go ahead and download to your computer for you. All right, so with that stuff out of the way, I want to give a little bit of an introduction as to what we're going to be doing today. So again, welcome to the Tutor.com Come and Learn webinar series. Today's webinar and presentation is all about dimensional analysis. This could also be known as unit conversions, the unit factor method. There's all different kinds of names for it. And this particular technique is used in several different subjects. So you may see it in algebra or chemistry or some of your nursing programs. Accountants even use it when it comes to currency conversions. There are many different ways that we may use dimensional analysis and unit factoring, and we know that it's an area many of our students struggle with. So we wanted to provide this extra opportunity for you guys to come and learn with us. Throughout the presentation, we're going to have Winona Young, who is our subject matter expert here at Tutor.com, presenting the concepts behind dimensional analysis, and then she'll go work through some examples for you. we invite you to ask questions. We want this to be as interactive as possible. So please use that question box and send your questions in for us. Again, we'll go ahead and answer those after each different example. All right, I do actually see a question already. Somebody having problems finding the view portion and handouts. And just to let you know, we are going to be sending out some emails after the presentation is done. They should come usually within 2 to 3 hours once we end. Those will include a link to the recorded version of this webinar so that you can go back and view it again. And then you'll also get a second email that includes a link to a survey. We are giving away 2 $50 Amazon gift cards to those who complete through a random drawing. We have 2 of them for everybody that completes the survey. This is something new that we're trying, and so all of the feedback you can give us can definitely help us improve and decide whether this is something we should keep doing. So look for those emails. One will have the recording, another will have a link to the survey, and I will be sure to include an attachment to this PowerPoint presentation for you as well. So if you can't get it from handouts, don't worry, we'll give you a second option. So with all of that being said, I am going to go ahead and hand this over to Winona, and we're going to get started in our Come and Learn about dimensional analysis. So Winona, I will pass the management and screen sharing over to you.
Okay.
There you go. All right, we're off and running.
Okay, are we, does everyone see the title page? Are we okay?
Yep, looks great.
Awesome. So again, welcome. My name is Winona Young, and I'm one of the mentor managers for the area of mathematics for the Princeton Review Tutor.com, and I just want to welcome you to our webinar on dimensional analysis. Dimensional analysis is a skill that is essential to not only healthcare professionals, but as Susan alluded to accountants, and the ability to use this in many fields and many disciplines is really important. And so with that in mind, the purpose of this webinar is really to provide an overview of dimensional analysis and provide some relevant examples. Our specific goals today, we want to make sure that we define dimensional analysis, that we offer you a problem-solving plan for dimensional analysis problems, offer examples at various levels, explain connections to various subjects and disciplines, which we'll see through the examples that we use, explain how Tutor.com can help students, and then of course we'll offer a time for question and answer and provide some next steps for you. So let's jump right in. What is dimensional analysis? You may know it as different names, and Susan gave us some of these names, the factor label method, the unit factor method, the unit conversion method. And essentially, it's a way to convert quantities from one unit to another unit. It's based on the multiplicative identity of 1, which basically says that I can multiply any quantity by the number 1, and that quantity won't change in value. So we learned a few of these early on. We learned that 5 times 1 is 5, and 6 times 1 is 6. Whatever I start with, if I multiply by 1, I get the same thing. And then transferring that knowledge to algebra, we saw things like x times 1 is x, or y times 1 is y. And so the difference here with dimensional analysis is that we're using conversion factors to serve as our units or our 1. So it won't look like the number 1, but it's representing the value of 1. Before we get into some examples, I wanted you to see some common conversion factors that you may use. Some of these factors help us convert within the same system, so metric to metric or standard to standard, but there are others that provide a means for converting between systems. Of course, this list is not an exhaustive one, but I think it's enough to get us started on the examples that we have for today. Another important concept that we need to understand when we're converting units within the metric system is conversions that change with exponents. So we have these prefixes: mega, kilo, centi, milli, micro, nano, and there are others. But what I want you to notice here is that when the exponents are positive, for example, here with mega, kilo, the quantity itself gets larger. But when the exponent is negative, here with centi, milli, micro, nano, that the quantity itself gets smaller and decreases in size. We won't use those today, but I wanted you to have that information. Okay, one of the things we want to make sure that we have when working with dimensional analysis problems is a good approach. And so it's important that we come up with a standard approach to problems, one that you can use across any type of dimensional analysis problem that you may encounter. And so this infographic will kind of provide that standard approach for us. The first thing we want to do is to identify the information that we're given. Usually this will be provided in the original units, and we want to set the equation up so that this particular information appears first in the equation itself. Once we identify the given information, we then want to begin to identify conversion factors that will help us get from the original units to our desired units. Things to note: multiple conversion factors may be needed. And one thing that's very important, because most of these are going to be set up as fractions, and we're using fractions to represent a division of sorts. We want to make sure that we set up conversion factors so that units can cancel top to bottom. And we'll see more of that in our examples. Once we've identified those conversion factors and set them up, then the last step we'll have would be to multiply and sometimes divide to achieve whatever the desired answer is with the appropriate units that we've been asked to find. You want to make sure that your final answer always includes the units, and if your instructor requires it, make sure you include any sig figs or significant digits. Again, this particular approach can be used for each problem that you as a student may encounter. And so let's take a look at a few examples and see how this goes. So for our first example, we're just going to begin with something pretty common just to get our feet wet. So suppose we want to find out how many seconds there are in one day. We start with the given information. The only thing we have in this question is one day. We know that for a fact. So we're dealing with that given information. Then we want to think about what factors will allow us to get from days to seconds. And so when we think about a day in terms of time, we might think about the fact that there are 24 hours in one day. And so, of course, if we're trying to get to seconds, hours may break down to minutes. So there's 60 minutes in 1 hour. And then we can break down from minutes to seconds by recognizing that 1 minute is equivalent to 60 seconds. And so with these conversion factors in mind, we can set up our equation using these factors as ratios. So to set up our equation, again, we want to begin with the unknown, which is 1 day. The unknown is seconds, and we're given 1 day. And so when we're dealing with conversion factors in dimensional analysis, we might want to apply one of the 7 habits by Stephen Covey, which is begin with the end in mind. So the plan is to eliminate all units and only be left with seconds. So by beginning with that given information, we're going to write it as a ratio or a fraction, and we're just going to use 1 as the denominator, making that quantity still equivalent to 1 day. All the other ratios and fractions will be written based on their conversions. Again, the key to placement of the units is understanding that we want to treat these units as canceling factors. And in order for units to cancel, the same units must appear in the numerator or the top of the fraction, as well as the denominator or the bottom of the fraction. So we'll start with our first conversion factor, that there are 24 hours in 1 day. So you just notice again the placement of the unit here. We want to cancel days. So I made sure that 1 day was in the denominator of this conversion factor so that it can cancel with the numerator of the previous conversion factor. So days are canceled. And now we're left with hours. But keep in mind, again, we want to know how many seconds there are in a day. So we can use our next conversion factor, which reminded us that there were 60 minutes in 1 hour. Again, here we can cancel hours in the numerator with hours in the denominator. And so now we're left with minutes, and we can use our final conversion factor that shows there's 60 seconds in 1 minute. Minutes are canceled, and now we're left with the units that we're interested in, which are seconds. So now with the units out of the way, all that's left to do is the math, and you literally want to multiply across the numerator and then multiply across the denominator and divide. And so we're showing 24 times 60 times 60. Essentially, we're dividing by 1, so it's not necessarily to show that. And so here we see that there are 86,400 seconds in 1 day using dimensional analysis. And so I'll pause right here since this was our first example and see if there are any questions that we want to address.
All right, so we did get a question with a follow-up in here, and you've actually already addressed one of the questions, which is whether there's any easy shortcuts when doing the unit conversions, especially in Algebra 1, and whether or not it's possible to do mental math for these.
Mm-hmm. That is a great question, and it's actually one that'll come up in our last example. I believe I will answer the question, yes, it is possible to do mental math. So for example, someone might know how many minutes there are in 24 hours, and you may not need to multiply that 24 by 60. You just know there's 1,440 minutes in a day, and then you would go ahead and convert that to seconds. That is an acceptable method to use. My only caution would be to ensure that what your instructor wants. If your instructor wants to see every conversion appear as a factor, just make sure you follow your instructor's expectations on that.
All right, thank you. No other questions have come in at this point in time, but you guys in the audience, I definitely invite you to go ahead and put those questions in the question box as we're going along. So Winona, if you want to go ahead and continue on to the next one, that would be great.
Awesome. All right, here we go. So that one might have been a little painful. These examples are a little corny, so forgive me. So let's take a look at a nursing example where we can take some Tylenol for our pain. Here we have a patient who needs 650 milligrams of acetaminophen. That Q stands for every 6 hours. That PRN is as needed for mild pain. Tylenol comes in 325 milligram tablets, and so as a nurse or a nursing assistant, you might need to know how many tablets this patient should receive. So again, we're going to follow that standard approach by writing the unknown quantity first, or what we want to know, what we want to find out. And what we want to find out is the number of tablets needed, and we're going to follow that up with the given information. We're told that there are 650 milligrams of acetaminophen, that the patient needs 650 milligrams of acetaminophen. And so here we're told that each tablet of Tylenol contains 325 milligrams of acetaminophen. And that one statement helps set up our next conversion factor. So that's what we'll use. We just want to make sure, again, that we list the units in an order so that milligrams will cancel out. And so as we write that conversion factor, that lets us know that milligrams should appear in the denominator of that conversion factor, while tablets remain in the numerator. That allows us to cancel milligrams, the numerator and denominator, leaving the unit that we're interested in, tablets. And so now we just divide 650 by 325. That 650 came from multiplying 650 times 1 across the numerator, and 325 came from multiplying 1 times 325 across the denominator. And then dividing those two numbers, we find out that 2 tablets is the number that this patient would need in order to get the 600 milligrams of acetaminophen. So that one was a little I guess less, if you had fewer conversion factors, I'll put it that way, than the first example, but certainly a different context. So are there any questions with this example?
Yes, there definitely was one, and it's great that you mentioned this one's a little bit shorter, because the question is, how do we know when we have to do two conversions for one problem?
That is an awesome question. And from personal experience, my daughter is actually taking a healthcare class this semester in high school, and they've had to do lots of different conversions. And if you go back, if you have your handout and you go back to that table of conversion factors, there will be several different conversion factors for different quantities. So for example, if I want to convert inches to feet, I can use 12 inches equal 1 foot. If I want to convert feet to yards, I might be able to use that 36 inches, that 3 feet equal 1 yard, or that 36 inches equal 1 yard. So sometimes it depends on which conversion factor you choose to begin with. And depending on, again, whether or not you're going to be provided with different conversion factors or whether or not you're going to have to memorize different conversion factors will determine how many you have to use. In the first example, we could have very easily used just one conversion factor if we already knew how many seconds were in a day. We could have used that conversion factor and then all done with it. However, I don't know if that's information that people walk around just for trivia's sake knowing. Some might. But the number of conversions really just depends on which conversion factors you can recall at the time when you're solving the problem.
All right, wonderful. At this point in time, there's no other questions in the question box, but we do have another example. So for those of you in the audience, again, please feel free to enter those questions in for us as we move along to the next.
Okay, here we go. This one will be another multiple conversion example. There may be times when chemistry students need to find the number of atoms that are contained in a compound. So as we look at this example, we want to find the number of atoms contained in a specific amount of a single element. Suppose we want to know the number of atoms that are contained in 10 grams of gold. We can use the atomic mass of gold, which has the symbol of AU in the periodic table, along with Avogadro's number to make multiple conversions. So we're going to set this one up similar to the previous example, list the unknown out front. That's the mass of gold, and then 10 grams. But we don't have a direct conversion factor that tells us how to find the number of atoms in 10 grams of gold. So that's why this problem will require multiple conversions. The approach we want to take here is we're going to move grams to moles, and then we're going to move moles to atoms. Now, there's some background information you would need to know here. So from the periodic table, we would need to pull in the molecular weight or molecular mass of gold, and we find that that number is 196.967 grams. And then Avogadro's number is the number that tells us that how much 1 mole of any element contains in terms of elementary particles. And in this case, that would be atoms. So I've written this here as 1 mole of gold equals 6.22 times 10 to the 23 atoms of gold. And this number 6.22 times 10 to the 23 is a constant, and that is Avogadro's number. The second piece of information is what would come from the periodic table, and that is that 1 mole of gold is equal to 196.967 grams, and that's because the mass of 1 mole of any substance is also equal to that substance's atomic weight. So there's a bit of chemistry background that's involved in this one to help us understand how to pull those conversion factors in. So these are the two conversion factors we'll use. So again, we started out with number of atoms in gold as our unknown, but we're given that we want to begin with 10 grams of gold. So with correct placement of the molecular mass conversion, we can cancel out the grams units. So since grams is in the numerator in the conversion factor I have set up, then I want to make sure that grams are in the denominator of the next conversion factor. So our grams of gold in units will cancel out. And so now we're left with moles, and we want to change moles to atoms. So now moles appears in the numerator of this conversion factor. So when we set up the next conversion factor, which is the top bullet point we see here, that 1 mole of gold contains 6.22 times 10 to the 23 atoms of gold, we just want to make sure that moles appear in the denominator, of the next conversion factor. And so our moles have disappeared. And we are left with the units that we were after, which were atoms of gold. We multiply across the top, multiply across the bottom, and divide. And once we divide, we find that there are 3.056 times 10 to the 22 atoms of gold contained in 10 grams. So this one's very interesting, a little bit of chemistry background there, but the process for dimensional analysis still following that standard approach. So I'll pause once again and see if there are any questions outstanding.
Yes, we did get another great question, and actually we have two. We'll start with the one that is relevant to this particular question first, and that would be why 6.022 in the equation? So maybe talking about Avogadro's number a little bit there?
Well, I have asked that question one more time.
Why do we use 1 mole equals 6.022? Times 10 to the 23rd.
I see. If you're asking about the number itself, 6.22 versus 6.022, this is a typo, and I need to fix that. Susan,
All right, there we go.
Okay, but the correct number is 6.22 as opposed to 6.022.
That was a great catch, Heidi. Thank you for getting that for us.
Yes, I appreciate that.
Yeah, we see it correct in the explanation right above. 1 mole of gold equals 6.22 times 10 to the 23rd. You can tell I've had to rattle that number off many times in my life.
Lots of times. Mm-hmm.
Yes.
Oh, sorry. I didn't mean to change that.
That's okay.
There we go. Now that will change our answer slightly as well, and we'll correct that. But instead of 3.056, it should be 3.158.
Okay.
So we'll adjust that in the final
158
presentation that we send out.
Excellent. All right. And then
nice catch. Thank you.
Yeah. The other question we have, and this is a really good one too, and I want to hear how you would answer this. We have someone who has struggled a lot with dimensional analysis. The first time it was introduced to them was in 6th grade as they're going through the middle school math, and now they're up into advanced algebra. From your experience, do you think that dimensional analysis will get harder and more complicated as the attendees start to approach higher level classes?
That is a great question. So here's how I'll answer that. I am a former math instructor. I taught high school math, and I taught all levels, from our struggling learners all the way up through AP classes. And one of the things that I've found to hold true with any concept that I've taught that has transitioned from one level of class or grade to the next is that if we focus on an approach that works for every type of problem, and if we focus on conceptually understanding that idea, then that knowledge can be transferred from level to level, regardless of what class we're in. So whether it's middle school math to advanced algebra, or if it's advanced algebra to your physics or chemistry class, if we have a good foundation and a good approach, then while quantities may look different and units may look different, the approach that can be applied doesn't change and should lessen maybe any anxiety a student may feel or any concerns about encountering new topics that a student may feel, even though we're using the same approach. And so that's why I tried to choose here something that I thought would work across the board. Start with what you don't know. Set that up first, and then fill in what you're given, and then just try to think of what conversion factors may work. Now, I mentioned earlier that my daughter had this unit in her healthcare class, and when she did her homework and they went back to class and compared, what they found was that several different students may have chosen different conversion factors to get from one unit to another unit, but their final answers were all relatively close. They may have been off by like 100th of a decimal place or 1,000th of a decimal place, but there was no one who used correct conversion factors that got an incomplete or completely different answer than anyone else. So again, to kind of summarize, I would say find an approach that works. Be confident in choosing conversion factors that you know will get you from one place to the next. It's really like a puzzle. It's like, which piece do I choose next? And then make sure you're following that rule of placement in your numerator and denominator so that the units that you want to cancel will actually cancel out, leaving you with the units that you're seeking.
All right. And I have to say, I 100% agree. As a former chemist, I was doing this all the time in my job. And while the units sometimes looked scarier because I wasn't familiar with them, as long as you follow this process, and my teacher used to call it the railroad tracks process because he sort of turned it sideways and thought it looked like railroad tracks for some reason. As long as you follow that same approach over and over and over, and always, always, always keep track of your units, don't skip putting the units in the problem, then the concept doesn't get any harder, even if the subject does. That's what I always found. Yeah.
Awesome.
All right. So, and just one more note on this. Heidi did bring up that this the 22 instead of 23. So we'll make sure again that this is corrected to 6.22 times 10 to the 23rd, and that we have the exact 100% correct answer on the bottom of that slide before we distribute the PDF over to you guys via email. So, all right, so let's go ahead on to the next.
Okay, this one will be our final example, and it's a doozy, but we can do this, okay? All right, so let's take a look. Because you're over-dimensional analysis problems, you and two friends decide to drive to Mexico City from San Diego to escape your sorrows. Road trips can be really fun. All right, so your friends agree to chip in for gas, but need to stop by the ATM before leaving. The current exchange rate shows that 1 peso is worth about 5 cents, and gas costs about 5.8 pesos per liter. Your car gets 21 miles to the gallon. So we want to know how much each person, including yourself, will need to contribute for gas in US dollars to get to Mexico City and back, considering that San Diego is 2,813 kilometers away from Mexico City. So there's a lot of information given in this problem, but we're going to take this slow, take it step by step, and follow that same approach that we've been using for previous examples. So first, let's start with conversion factors that we were given. Here's some things that we can pull from the scenario. We were told that 1 peso is equal to 5 cents. That 1 liter of gas costs about 5.8 pesos, that the car gets 21 miles to the gallon, so we can use that as a conversion factor of 1 gallon to 21 miles, and that a one-way trip from San Diego to Mexico City is about 2,813 kilometers. And so to the person who asked that last question of, what if it gets more difficult, we're still following that same approach. And so our next step is now to think about, what are we missing? What are some conversion factors, or what are some changes that we would need to make in units in order to make this problem a little less daunting for us? And I actually want to open it up at this point and just kind of see what you would throw out there. So what are some things that we might need to convert from what unit to what?
Oh, good question, you guys. Go ahead. Kilometers to miles we have.
Awesome. Kilometers to miles. Yes.
What else, you guys?
Think money.
Pesos to cents. Okay, we got the pesos to cents on top.
But we want dollars. So we could definitely go dollars to, or cents to dollars.
Yeah.
Any others that you can think of out there? And if not, it's fine.
Not seeing any others coming in.
Okay, no problem.
Oh,
I'll give
gallons
you
to liters. Gallons to liters. We got
Gallons
good
to
catch.
liters.
Good catch.
Excellent. Excellent. And then there's just one more that we may not think about because in our heads it seems kind of trivial, but we definitely need to convert a one-way trip to a round trip because we want to get back home. So those are some of the conversions that are missing. And so what we're going to do again is follow that same approach. We're going to start out with US dollars in front because that is what the question has asked us about. How much money in US dollars would each of us need to pay for this trip? And other information that we're given, we know that 3 people are taking one round trip. And again, as trivial as that information may seem in a problem, that can be used in a conversion factor in this situation. So my goal in this problem, because there's so much information, is to follow a path that seems as logical as possible. So what I want to do is actually begin with information about the trip itself. So again, we start out knowing that one round trip, 3 people are taking one round trip. Let's talk about round trips and one-way trips. Because we're going to one city and back, 2 one-way trips are going to make up a round trip. Again, as silly and as trivial as that might seem, that is a conversion factor that allows us to cancel out round trips. We can set that up and then units cancel. And so now we're left with one-way trips. So another piece of information we're given is distance. We were told that a one-way trip was 2,813 kilometers. So let's use that conversion. Again, we're paying careful attention to placement so that one-way trips can cancel. And now we know that 3 people are taking a trip that will consist of 2,813 kilometers one way. And notice we have the 2 remaining in the numerator to show the round trip. So one-way trips are no longer a concern. We're going to get back home. That's not a problem. I think Susan brought this up earlier. I do find that it's a bit easier to cancel units as we go. Kind of jars the thinking into what we may want to do next without looking at all of the units that are left, especially for problems that will have as many conversion factors as this one. All right, so let's continue. We now have kilometers per person. We're looking for US dollars per person. So let's deal with converting the standard units of kilometers, or the metric units of kilometers to standard units of miles. So this wasn't shown on the screen, but there are about 1.61 kilometers in a mile. And so as we set up this placement, 1.61 kilometers versus 1 mile, I want us to think about placement here. So I'm opening this one up just so that we can participate. I want to know which unit should be placed in the denominator as we set up this conversion factor. Should kilometers be placed in the denominator or should miles be placed in the denominator?
We have one answer so far, but let's see if more come through. So are we asking for which one on top or which one on bottom?
On bottom. So in the next conversion factor, which unit should go in the bottom, kilometers or miles?
Excellent, excellent. We are seeing all of the same. It is a unanimous decision that kilometers should go on the bottom and miles on top.
Excellent. Because we want to cancel kilometers, we do want to make sure they appear opposite the previous conversion factor. So we want kilometers in the denominator and miles in the numerator. Good job. And so now kilometers are gone and we are at miles per people. Now, we've done lots of conversions so far. We're about halfway there. Hang in there with me, okay? All right. We know how many miles the car can go on a gallon of gas. So notice the logic that I'm following here is what unit am I left with? And then what information do I have that relates to that unit that I'm left with? So the unit I'm left with is miles, and I was given information about how far a car can go in miles. And that piece of information related to how far that car could go on 1 gallon of gas. We also know that gas in Mexico is sold in liters. So we're going to make a couple of conversions here. The first one we're going to make has to do with the car mileage, that 1 gallon to 21 miles. The car can go 21 miles on a gallon of gas. Miles is in the denominator. That will allow me to cancel miles, leaving gallons in the numerator. And then I can use the information of liters to gallons based on the way gas is sold in Mexico. So we need to have a conversion factor that is acceptable for that, and I happen to have one here. It shows that there are 3.79 liters to 1 gallon. And so this is actually going to drop down in a new line, but we still have gallons in the bottom to cancel with gallons in the top of the previous conversion factor. And so gallons are gone. So now I need liters. Now I'm going to ask and pause again for some help on this one. We did have some information given in the stem of the problem that talked about liters. What did they tell us about liters?
Anybody remember? What was in the liters?
So much information there right now.
Yep, we got 1 liter equals 5.8 pesos. So
perfect.
Sell for.
Excellent. Thank you so much. So let's use that. Let's get that in here. We want to cancel the liters, so the pesos will appear on top. The liters will appear in the denominator. Liters, goodbye. You're out of here.
All right.
So now we know how many pesos per person. At least we have money per person. We're getting a lot closer to the end. Now we just need to convert pesos to dollars, and we're all set. So we had a conversion factor for pesos to the US amount, and that was that 1 peso is worth about 5 cents. Now we can use that, and we do have some options here, and this question did come up earlier. We can, go ahead and convert cents to dollars mentally and say, oh, that's about $0.05. Or we can go ahead and use multiple conversions. Again, I'd recommend that we go with the multiple conversions for 2 reasons. One is silly, but we've already done 8 of these, so what's one more? But more importantly, your instructors may want to see all of your conversions worked out on your paper rather than in your head. Again, as a former teacher, there's something about showing your work that allows us as teachers to trace your thinking while you're working, and it's a lot easier to maybe point out where the thinking went left and kind of bring you back into a right form of thinking to get your problems right. So we're going to go ahead with the multiple conversion, as silly as it seems. We're going to go ahead and use that 5 US cents per peso. Pesos will disappear. And then, of course, our grand old penny, there are 100 pennies to $1. But this time the pennies go in the bottom to cancel with the US cents in the top. And guess what? We're done with the dimensional analysis part. Yes, give yourselves a hand. We have US dollars per people, which is exactly what we wanted. And so now all that's left to do is to multiply. So I actually multiplied all these out so we could see how this goes. So across the numerator, we have 1 times 2 times 2813 times 1 times 1 times 3.79 times 5.8 times 5 times 1. That's a lot, but we did it. Mm-hmm. And then in the denominator, we have 3 times 1 times 1 times 1.61 times 21 times 1 times 1 times 1 times 100. And so what we'll do is multiply across the top first to get a single number, then multiply across the bottom to get a single number, divide those 2 numbers, and it turns out that this trip would cost us about $61 per person. So is it worth it? to kind of escape doing dimensional analysis problems? I think a lot of us would probably say yes.
No, we should hit the road.
But
Yep, we should hit the road for that amount.
yes. So that is the end of the problem and the end of the examples. And this was a long one, and we did have some interaction throughout, but I definitely don't want to miss the opportunity to answer any questions that there might be out there about this particular example.
All right, you guys, now's the time to go ahead and put those questions in about this one. I actually have a question for you, Winona, for myself, so I can help my own kids. When entering a problem of this length into a calculator, would you suggest using parentheses over the top multiplications and then hitting divide, and using parentheses again over the bottom? So it's like open parentheses 1 times 2 times 28, 13 times, all of those, then close, and then divide and do it again, open parentheses 3 times 1 times 1. Is that the best way to make sure you get the most accurate and don't put something in the wrong order?
Susan, the calculators these days are so fancy.
I know, that's why I ask.
So much for you, but we do still have to follow order of operations. But, the calculator, as fancy as it may be, is only as useful as the information that we provide for it. And so putting parentheses around the numbers in the numerator and then separately around the numbers in the denominator is definitely an efficient way to make sure that order of operations is preserved and that it is correctly calculating numbers top and bottom before dividing. I've also seen some students just do it separately. Let me just multiply all of the top, press equal or enter, get that number, and then separately multiply everything on the bottom, press enter, get that number, and then divide them. So it is a matter of preference, but we always want to keep in mind when using calculators how that particular calculator deals with order of operations. Again, parentheses is the safest way to ensure that your numbers are being computed first before any other operations are taking place.
Okay, excellent. That does help quite a bit. And then we have another question on the final answer. Can you multiply that out again for your numerator?
Sure. Let's see here. I'm doing it right now. I'm glad I pulled my calculator out of the drawer before you started here today. 5.8 times 5 times 1. 61853. 618. Oh, there's a 3 missing.
Another good catch there, you guys. This is fantastic. I think it's great to learn by watching others and being able to catch those mistakes. That means that you've been following along and understanding the concepts wonderfully.
Excellent.
And it also means that we can be a little too fast when we put this math together, the numbers together.
Absolutely. Admittedly so. So that corrected value should be 618,353.66.
Perfect.
And then the final answer is not changing there.
Yeah.
We just left
Just
out
the typo again, leaving that out. And then we do have another question here. So let me read this first. What was the step you did as you were making the list of units you needed, like pesos to dollars, liters to gallons, etc.? That continues. I have found that instructors hit on the setup only and not that particular step. So I think it's important for new units and such for students in real life. So is there a way we can go back to the previous slide?
Let me see if I can get there quickly. Excuse all of these things sort of doing.
All the animation.
I wish I could get there faster.
There we go.
Okay, are we talking here?
Yeah, I think that's the one. So identifying, identifying your given conversions and then what you're missing. I think those are great.
So for me, and I used to do this in my classroom, I call them think alouds. It really is a thought process. So as I'm listing what's given, okay, you told me about pesos and cents. You told me about gas, or liters, excuse me, in pesos. You told me about gallons and miles, and you told me about a one-way trip in kilometers. So I have a car, and this is my think aloud. I have a car, and I know how many miles are to the gallon, and I know that miles is distance. But then I have something over here in kilometers, and kilometers is also distance. But I don't have anything in my problem that told me how to get from miles to kilometers. So that must be a conversion factor that I need. Or the same thing for liters to gallons. So maybe in Mexico they sell things in liters, but here in the US we sell things in gallons. And so I have these two different quantities, and I don't have any information that's been given of how to convert from one of those quantities to the other. Okay, so that must be a conversion factor that I'm going to need to use later on. And then the one-way trip to a round trip, that one, honestly, I think a lot of students will miss because it seems so simple and so meaningless. And at the end, they might kind of go, oh, yeah, that's a one-way trip, so I need to multiply by 2. But by putting it as a conversion factor, again, it helps to follow that standard approach that we've set up. And the same with cents to dollars. You know, as I mentioned earlier when we went through the problem, that might be one where we feel like we can just do that in our heads. And some might do it in your heads. Again, follow your instructor's guidance on that. But I'm definitely going to need a way to get from pennies to dollars, whether that's mental math or a physical conversion factor. So it really is just a matter of slowing your brain down long enough to say, this is the information I have, and this is the information that I need to end up with. And again, like a puzzle, what pieces do I need to put in place to help me get there? Every problem will be different, but the approach should not change. And that may not give as specific of an answer as you were looking for, but it's a problem solving, thinking kind of process.
Yep. I 100% agree. I always used to list out any conversion that I could think of that had to do with that problem. And when we're showing it in PowerPoint, I think that the whole picture may not come through as much because you can't view this slide at the same time you're viewing the other slide where we're actually working the conversions. But when you're doing this in a notebook and working on it at home, you guys can have, you know, one section of your paper or even a scrap piece of paper over to the side where you list out the conversions, just as Winona did here. And I think that helps keep track of things quite a bit. So, and then I'm looking, Winona, we did have a couple other questions coming in that are a little bit higher level concepts or information here. One is, are there different methods to solving conversions? Is there something other than this dimensional analysis kind of thing that you've heard of before?
That is a great question. And the answer is yes. I do think that, believe it or not, it's crazy, you know, especially as that last example was, as the examples are that we've done, dimensional analysis is really rooted, and this is actually something I was going to bring up on the next slide, it's really rooted in algebraic reasoning and proportional reasoning. So notice everything we set up was set up in the form of a ratio. So if we wanted to solve these in a different way, we would probably need to set up, and if I say it this way, it doesn't make sense, I'll explain again. We would need to set up pairwise proportions. For example, we might need to say 1 peso over 5 cents equals 100 cents over X dollars. And then cross multiply to find the dollars. And then we would need to take that conversion factor and set up another proportion to help solve for a different one. And while that method is one that would work, it's not very efficient as compared to what we've done here with dimensional analysis, especially when you have multiple conversions to make. The example where we did the Tylenol tablets to acetaminophen is a perfect one that could have been used using algebraic proportions. You cross multiply and you're probably done in 2 minutes or so. But one like the example we just did does not lend itself well to solving problems that way.
Okay, excellent, excellent. And then the other question you might actually, we've touched on it a little bit already, and you may go into it a little bit deeper, I'm not sure. It is, in what careers can I find dimensional analysis helpful?
Okay, so what I'm going to do is go to almost the last slide.
Okay.
Because these questions are kind of coming up in the closing. Ignore all of this craziness going on the screen right now.
There we go. Oh, perfect.
All right.
Look at that.
So in these examples, we did nursing for dosage calculations, chemistry for finding the number of atoms in compounds, algebra for proportional reasoning. I know Susan mentioned as a chemist, this was something that she did. Nursing and anything in the healthcare field is huge, because nurses and nursing assistants are always the ones calculating how much to put in your IV. So if that's a field that you're planning on entering into, dimensional analysis is your life, as they say. So you will definitely need to have a strong grip on this. Physicists, engineering also would use dimensional analysis. In physics, you have so many different formulas that relate motion, like velocity, acceleration, and then those carry over into engineering if you're trying to make conversions, feet to yards, or I don't know, cost to square footage or something like that. The number, I guess I would say, of careers or disciplines that might use dimensional analysis is really endless. And again, sometimes we don't recognize it because it's something that we're doing every day, really, without even thinking about it. If you cook or bake, you're constantly converting teaspoons to cups or pints to cups or something like that. So daily life is also a discipline, if we want to call it that, where we're going to find dimensional analysis. But I really don't think we can put boundaries on which careers. Mm-hmm. I've definitely used them in education. I've used them in accounting. So again, limitless here.
Yeah. Just thinking about construction, if you have to figure out how many boards, 2x4s you need to purchase of a certain length, it can be found in every single thing that we do every day in life.
Mm-hmm.
And I think we do it when we don't even know we're doing it. They just put a big scary name on it to, make us all go, yeah. So, okay, with this slide up, and I think this is the method that you may have just explained, proportional reasoning. Is that what you're talking about with the cross multiplying? Because somebody asked what is the definition.
It is.
Of it.
And proportional reasoning, good question, great question, thank you. Proportional reasoning really has to do with, I have a set of values that are equivalent to another set of values, even though they may look differently. And so maybe the earliest that we would have encountered something like that may have been fractions, equivalent fractions, where we found out that 1/2 was the same as 2/4, was the same as 3/6, excuse me. Or when we did decimal percent conversions and we found out that 10 cents was the same as 10%, which was the same as a fraction 1/10. So if I take any of those quantities in their states and just apply some type of conversion factor to it, whether it's doubling or tripling or halving them, let's take the 0.5 and the 50% and the 5/10. If I double each of those, then I get, as a fraction, I get, 2/4. As a quantity, I get, the 50, then that 2/4 still changes to 50%. And if I simplify, it still changes to 1/2. So even though I'm multiplying by some factor, these two units still have equivalent forms, or these two quantities still have equivalent forms. Or, let's say, I could talk triangles. So let's say we have a triangle and the sides are 3, 4, and 5. And if I decide to double the length of each side of that triangle, now the new triangle has side lengths of 6, 8, and 10. Although these two triangles will not look the same, they are proportional to each other. One is just twice the size of the other, or the smaller it's half the size of the other. But that's what we mean when we talk about that proportional relationship. Some factor has been applied, whether that factor makes the quantity larger or smaller, they're still equivalent in some way.
All right. Excellent. And with that, we have about 2 minutes left. And so I know, Winona, you wanted to just show them really quick about how they can get help on dimensional analysis through their school or libraries or the military Tutor.com program. So if we want to talk about that a little bit and then sign off, will be great.
Absolutely. Thank you so much. So how can Tutor.com help? Well, we're available for live online tutoring. There are also practice quizzes available in various subjects. I'm going to toot a horn here. Shameless plug. I have used Tutor.com as a student in grad classes and been very successful with our tutors. My children have logged on and received assistance for Tutor.com for high school, middle school, and even I think elementary school classes, and have had success as well. You do want to check with your school or your library for how to access and which subjects may be available for you to receive help with. But this is a screenshot of how the platform looks when you sign on as a student. You would choose your drop down here for the topic that you want assistance with and subjects you want assistance with. If you select a grade, that helps give the tutor a little bit more information about what level of student we're working with. And then even here, there's a place where you can directly enter the question that you want help with. So once you are connected with a tutor, you'll be ready to go.
All right. Thank you. And next steps?
All right, so next steps. So after the webinar ends, we're definitely first going to make some corrections before we send these handouts out to you. And you can look for the recording via email within 1 day. And if anything else comes up or you think of other questions after the webinar is ended, be sure to contact us at studentsupport@tutor.com.
All right. Thank you so much, Winona. This was fantastic. I know that I learned and got some refreshers so I can help my own kids. And for those of you that joined us today, I hope you found it very helpful. And again, I encourage you watch for those follow-up emails and definitely fill out the survey for us. Let us know what else you'd like to see in webinars like this and how it went along. Provide us with feedback so we can improve, and we hope to see you in another Come and Learn webinar series soon. Thanks so much, everybody. Have a great day.
Bye, everybody. Thanks for joining.